Today I'm going to cover section 10.1, solving quadratic equations. Objectives: solve quadratic equations by factoring and the zero product rule. Solve rational quadratic equations by clearing denominators first. 1. Zero product property. The zero product property states that the product of two real numbers is zero if and only if one or both of the numbers in the product is zero. Symbolically, we have the following equivalents. A times B equals 0 if and only if A equals 0 or B equals 0. We can use the zero product property to solve polynomial equations by factoring, as long as the resulting non-zero side of the equation is factorable. Determine if the following equations can be solved using the zero product property. If they are not in the correct form, rearrange them to achieve the necessary form. So A is equal to 0. 3x squared minus 2x plus 9 equals 0. But I don't have any products. So first, in order to get it in the correct form, I need to factor it. So I'm going to use the AC method. So AC equals 3 times 9, which is 27. The factor pairs I need negative, negative. So we get negative 1, negative 27, negative 3, negative 9, and that's it. None of those add up to negative 2, so this is not factorable. So we can't use the zero product property. B. At first looks, it looks like we may not be able to use this because there isn't 0 on one side, but we can always just subtract x squared and add 5 to both sides. So then we get x squared minus 4 equals 0, and then that's a difference of squares, so x minus 2, x plus 2 equals 0. And then we could solve it from here. And then C, 3x to the fourth minus 4x squared minus 4 equals 0. So this is called a quadratic trinomial, so we can still use the AC method. So 3 times negative 4, which is negative 12. And then the factor pairs are 1, negative 12, 2, negative 6, 3, negative 4. And it's the 2, negative 6 that gives us the negative 4. So then we get 3x to the fourth plus 2x squared minus 6x squared minus 4 equals 0. And then factor by grouping. We can take an x squared out of the first two terms, get 3x plus 2. Then we can take a negative 2 out of the last two terms to get 3x plus 2 as well. And then factor out the 3x plus 2 with an x squared minus 2 left over, and now it's in the correct form. Once we have our equation in the correct form, namely polynomial equals 0, we can factor the left-hand side of the equation using strategies from Chapter 8, like we just did. And once the non-zero side is factored, the zero product property tells us that one or more of our factors is equal to 0. For example, if x plus minus 3 times 2x plus 2 equals 0, then x minus 3 equals 0, or 2x plus 2 equals 0. We can solve these simpler equations separately. Thus, the solutions are 3 for the first one and -1 for the second one. Example 2, solve the following equations by factoring and using the zero product property. Okay, so this one can be factored into x plus 3, x plus 4, because 3 times 4 is 12 and 3 plus 4 is 7. After you have it factored, you take each one equal to 0, and then solve them. So x equals -3, or x equals -4. B, 5x squared minus 10x equals 0. Well, I can factor a 5x out. And then set each factor equal to 0. Divide by 5, x equals 0. Or add 2, x equals 2. For C and D, we first have to get it equal to 0. So subtract 12 from both sides. -x squared plus 8x minus 12 equals 0. And it's always a good idea for your leading coefficient to be positive, so I'm actually going to divide by -1 first. So then we get x minus 2, x minus 6, because -2 times -6 is positive 12, and -2 plus -6 is -8. Then we take them each equal to 0 separately. Add 2, add 6, add 6. So x equals 2, or x equals 6. D, 8x squared minus 3 equals 1 minus x squared. So again, I need to get it in the correct form, so I'm going to add x squared and then subtract 1. We get 9x squared minus 4 equals 0. Now this is a difference of squares, so that will be 3x minus 2, 3x plus 2 equal to 0. Then you take each one separately equal to 0. And then add 2, divide by 3, x equals 2/3. Subtract 2, divide by 3, or x equals -2/3. General guidelines for solving quadratic equations. Write the quadratic equation standard form, solve for 0 and simplify, factor the non-zero side of the equation, set each factor with a variable equal to 0, solve each linear equation, and check your answers. Part 3, solve equations with fractions. In a similar fashion to solving equations with monomial fractions in Chapter 4, we can now solve full rational equations. As before, our first step is to clear the denominators, which is done by multiplying both sides of the equation by the least common denominator of all the denominators in the equation. Once the denominators are cleared, we obtain a polynomial equation to solve as previously described. As in Chapter 4, remember to check each solution to see if it makes the original equation true or is instead extraneous. Example 3. Determine the expression needed to clear the denominators by multiplying it to both sides of the equation and then clear the denominators with it. This example is not asking us to solve. So for the first one, I can't factor 9x squared or x minus 2. So our LCD is just 9x squared times x minus 2. So I multiply everything by that. Even the right-hand side of the equation. So the 9x squared cancels out, and we get 3x minus 6. The x minus 2's cancel out, so we get negative 36x squared. And 0 times anything is 0, so we get 0. So there, we clean the denominators. Okay, B. 4x over 5 minus 10 over x minus 5 equals 1. So again, can't factor 5 or x minus 5, so the LCD is just them multiplied together. So I multiply everything by that. So 5x minus 5 times 4x over 5 minus 5x minus 5 times 10 over x minus 5 equals 5x minus 5 times 1. So the 5 cancels out, so we get 4x squared minus 20x. The x minus 5 cancels out, so we get negative 50. And then anything times 1 is itself, so we get 5x minus 25. So that's how you clear the denominators when solving rational equations. Example 4. Solve the following equations, first by clearing the denominators. Okay, so for A, we have 3x over x plus 1 minus 12 over x squared minus 1 equals 12. The first thing I'm going to do is factor that x squared minus 1 because it's a difference of squares. So x plus 1, x minus 1 equals 12. So then the LCD is not x plus 1 times x squared minus 1, but just x plus 1 times x minus 1. So I multiply everything by that. So the x plus 1 cancels out. We get 3x squared minus 3x. The x plus 1 and the x minus 1 cancels out, so we get negative 12. Then we get 12 x squared minus 1 after we multiply the x plus 1 by x minus 1 again. Distribute that 12. Get 0 on one side. So then we get negative 9x squared minus 3x equals 0. Factor out a negative 3x. Get 3x minus 1, plus 1 equals 0. So negative 3x equals 0, or 3x plus 1 equals 0. Then if we solve the first one, we get x equals 0, and then subtract 1, divide by 3, x equals negative 1/3. Now you do have to plug it back in to make sure it works. I'll let you check that on your own. Both of them work in this scenario. Okay. B, 7 over x minus 2 equals 10 over 3x minus 1. Well, since x and 3x minus 1 cannot be factored, the LCD is x times 3x minus 1. So then I take that times everything. Then with the first one, the x cancels out. So we get 21x minus 7. And then nothing cancels out for the second term, so we get negative 6x squared plus 2x. And then the 3x minus 1 cancels out, so we get 10x. So subtract 10x from both sides. Rearrange and combine like terms, we get negative 6x squared plus 13x minus 7 equals 0. And again, I just like everything being positive, so I'm going to multiply everything by negative 1. So we get 6x squared minus 13x plus 7 equals 0. Now the AC method, well, A times C equals 42. Then the factor pairs, which I'll abbreviate FP, of 42 are negative 1, negative 42, negative 2, negative 21, negative 3, negative 14, negative 6, negative 7. And that one works. So then we get 6x squared minus 6x minus 7x plus 7 equals 0. First two terms we can factor out as 6x, get x minus 1. The second two terms we can factor out negative 7 to get x minus 1, which equals 0. Factor out that x minus 1. We're left with 6x minus 7 equals 0. I'm going to have to go into the margin. So then x minus 1 equals 0, or 6x minus 7 equals 0. So x equals 1, or x equals 7, 6. And again, I'll let you check on your own, but both of them do work. And that's it for section 10.1.